In this video, we're going to look at a few examples of using and writing formulas. We're going to start with a pretty standard example of a simple formula, the one that converts Celsius temperature readings into Fahrenheit temperature readings. Here's the formula. Given a temperature reading in Celsius, represented by the variable C, you can plug in a value to this expression on the right side, simplify it, and that will give you the equivalent temperature reading measured in degrees Fahrenheit. So given the formula to convert degrees Celsius to degrees Fahrenheit, use this formula to convert 40 degrees Celsius. So the idea is we're simply going to start with our formula, F equals 1.8 C plus 32, but we're going to replace the C with this 40. That's our Celsius temperature reading. So a good idea whenever you're plugging a value into a formula like this is to use parentheses like I have here. Use those parentheses to show exactly where the variable used to be so that it's easy to see that you're replacing that by whatever you're plugging in this case 40. Alright, so let's simplify this. 1.8 times 40 is 72. And then 72 plus 32 is 104. That means if we have a temperature reading of 40 degrees Celsius, it's equivalent to a temperature reading of 104 degrees Fahrenheit. Let's do something else with this formula. Let's convert it into another formula where instead of plugging in a Celsius temperature reading to get out a Fahrenheit temperature reading, we'll plug in a Fahrenheit temperature reading to get out a Celsius temperature reading. So the relationship between Fahrenheit and Celsius is still described by this same equation. Notice that I wrote it a little different way this time. On the previous slide, we had 1.8 in front of the variable C. But that's exactly the same as 9/5. I'm doing it a different way here to illustrate that the formula can be used either with fractions or with decimals, so that we get experience doing it both ways. But also because in this particular case, it's going to turn out to give us a prettier formula if we use fractions. Let's see why. So the first thing I want to do is recopy the formula. F equals 9/5 times C plus 32. And I want to think about how I'm going to turn this into a formula where I plug in an F and get out a C easily. So what I really want to do is to isolate the C. I want to get this thing by itself. So how can I do that? Well, I can start by subtracting 32 from both sides of this equation. So F minus 32 equals 9/5 times C. Now I had plus 32 and then I subtracted 32. So those cancel and I'm just not even going to write them. Okay. This is the idea of moving something to the other side of the equation, but it's better if you think of it as subtracting it from both sides. Okay, and then the next thing I want to do is move this coefficient to the other side of the equation. But what's going on here is this coefficient is multiplying C. So when I moved the 32, I subtracted it because that's the opposite of this operation of addition. Now I want to do the opposite of the operation of multiplication. So to move this 9/5, what I actually want to do is divide by 9/5. And you might remember that dividing by a fraction is the same thing as multiplying by a reciprocal. So what I'm going to do is take what's already there and multiply it by 5/9. I do that to both sides of the equation. Whenever you're solving an equation, you always have to do the same thing to both sides. So I multiply both sides by 5/9, and the point of that is 9/5 times 5/9, those simplify. These 5's cancel, these 9's cancel, and you're just left with a 1c. So what we really have here is a c all by itself on one side of the equation, and on the other side of the equation we have 5/9 f minus 32. And there's our formula. By the way, notice how I switched the left and the right sides of the equation. That's perfectly legal. Feel free to do that whenever you want to clean up your presentation. Okay, one more example of working with equations. This time we're going to write our own from a description. In this example, we're told that a certain taxi company charges a fixed cost of $4.50 plus a per mile cost of $2.50. And we're supposed to write a formula for the total cost of a taxi ride in terms of the distance traveled. So first of all, let's introduce some symbols to represent the quantities we're talking about here. We've got distance traveled. I think I'll use a D for that. So D will represent distance traveled. And we're told that things are discussed here in terms of a per mile cost, so our distance should be measured in miles. And then I'll let T represent the total cost. And since things in this problem have been described in dollars, that's how we'll measure our cost, total cost in dollars. So how can I figure out the cost of a taxi ride? Well, no matter what, I'm going to be charged $4.50. That's my fixed cost. But then there's also a per mile cost, $2.50 per mile. And in order to figure out how much I'm going to be charged based on how far I go, I have to take this per mile cost and multiply it by the distance traveled. It might be helpful to think of this in terms of units. You have $250 per mile times d miles. And so if you think in terms of units here, when I multiply these two together, if I cancel the miles units, I'm left with 250 times d dollars. That's good because that has the same units as my $4.50 fixed cost, which means I can add those two expressions together. They have the same units. And if I do, that gives me the total cost of the cab ride measured in dollars. So this is a formula. I could plug in the distance traveled for D and get out T, the total cost.